Hi everyone, this is 10.2's post test, which is congruent and similar figures. A lot of similar figures has to deal with proportions, as similar figures have the same proportions of their sides, and their angles are all going to be the same. So if we look at this first example where it says the polygons to the right are similar, if you notice here, we kind of have two triangles. We have this little triangle here where we have y, x, and 17, and we're given this angle. And we have this bigger triangle here where it has that same marking of an angle. This side is 51, this side is 24, and this side is 45. So again, it's saying that these two triangles are similar, so that means their sides are going to be proportional. So we can set up a proportion of what we know. Um, I know all three sides of this bigger triangle. I only know one side of the smaller triangle, so I'm going to set up that proportion. I know the bigger triangle that matches with the side that I have is this 17 and this 51. So that's actually going to be my first proportion. I have 51 is to 17. So big triangle is to small triangle. And then I have to stay consistent. So my next fraction has to be big triangle to small triangle because I did big triangle to small triangle first. So 51 is to 17, and I'm going to find x first. So x matches with this side of 45. So 51 is to 17 as 45 is to x. And it creates this proportion. Okay, to solve, we have a fraction is equal to a fraction, so we can cross multiply to solve. So I have 51 times x, which is 51x, equals, and then 17 times 45, which is 765. And then to solve, I'm going to divide both sides by 51. 765 divided by 51 is 15. So I know that my x is going to be 15. Now, there is one other way to solve this, and just kind of looking at the relationship between the 51 and the 17. Okay, 51 is actually 3 times bigger than 17. Doing this post test before, I had a side that was 2 times bigger, so it might be different for everybody. But specifically mine, 17 times 3 is 51. So my bigger triangle is 3 times bigger. So if I look at my last side, the y side, if this side is 24, I know my y is going to be 3 times smaller. So I can take 24 and divide it by 3 to get y. So 24 divided by 3 is 8. So I know that my y is going to be 8. Okay, this next question, assume that the figures shown to the right are similar. So we know that they're similar. Given the lengths of sides and measures of angles in the left figure, what can be determined about the right figure? So the figure on the left, we have a couple sides and an angle. We know that this angle D here is 38 degrees. I know this side is 144, and this side AB is 216. So because they're similar, again, in similar figures, angles are exactly the same. So if this angle is 38 degrees, and this is a similar figure, I know that this angle also has to be 38 degrees. So that means the measure of angle I will also be that 38 degrees. And then, again, the sides are going to be proportional. So I'm given two sides of the left figure and one side of the right. So I can set up a proportion. So I'm going to do the big figure in the numerator. So I have 216 is to, and then in the denominator will be the small figure. So this 216 matches with this 132. So 216 is to 132 as, in the big figure I have 144, is to, and then that's going to match with this side here as IH or HI. So that's actually the side we're going to find. Okay, HI, which is this side that matches with this 144. I'm just going to call it X, but that's going to be that side that I'm solving for. So again, we can just cross multiply. So I have 216 times X, 216X equals, and then we're going to multiply the other diagonal, 144 times 132, which is 19,008. And then to solve for X, I'm going to divide both sides by 216. So I'm taking this number, dividing it by 216, and getting that X is 88. So this side here would be 88. Okay, the figures shown are similar. Again, these two figures are similar. And then find X, Y, and Z. Okay, so again, I'm going to look at the two sides that I know in both figures, so I know the proportion. So in this case, my big figure and the small figure, I know this side of both. So that's going to be where my proportion comes from. So I'm going to put the bigger figure in the numerator. So 24 is to 12. So that's my proportion. 24 is to 12. And then I'm going to match the sides with the variable I'm trying to find. So I'm going to try to solve for x first. So this 37 is the x side. So the 37 is the bigger figure, so that's the numerator. And then x would be the denominator. So 24 is to 12, 37 is to x. Okay, just like a couple problems ago, you can kind of see this relationship. 24 is to 12. So that means that this figure is twice as big because 12 times 2 is 24. So just something to keep in mind. We should notice that the smaller figure is going to be half the size. Okay, but I'm just going to do it cross multiplying just to prove. So 24 times x when I cross multiply is 24x. And then 37 times 12 is my other diagonal. It's 444. To solve for x, I'm going to divide both sides by 24. So 444 divided by 24 is 18.5. And 18.5 is half of 37. Again, I don't know if it's always going to be this 2-to-1 ratio, but mine happened to be. It just makes it a little bit easier. So if I look at y, if this side is 48, I don't even have to set up a proportion because I know it's going to be half. So if this is 48, I know y is going to be half that, which is 24. And then the last side, which is z, is 37. And then if I look at this, this is also 37. So x and z are actually the same length because these both are 37. And I already found what x was. So I know z is also going to be 18.5. Okay, the areas of two similar figures are in the same ratio as the square of the ratio of the two corresponding sides. The two figures are similar, find the unknown area. Okay, so this time it's saying the ratio is the square of the sides. So we're going to have to square the sides. So this ratio here is going to be the side to the area. But it says to square the side. So I'm taking the first side 3 and squaring it. So 3 squared is to the area of 26 as the similar figure, which has a side of 2, but I have to square that, is to the area that's unknown. So this is the proportion, and again I'm squaring the sides because it says it's the square of the ratio of the two sides. So you have to square the sides in this problem. So if I simplify this a little bit, 3 squared is 9, so this becomes 9 over 26 equals, and 2 squared is 4, 4 over x. So this is our proportion to cross multiply and solve. So I have 9 times x, which is 9x, equals 26 times 4, which is 104. To solve this for x, I'm going to divide both sides by 9. So 104 divided by 9 is this decimal 11.5 repeating, 55555 repeating. And it says round to the nearest tenth as needed. So that this is the tenths place, the first place after the decimal point. So I'm really looking at the second 5 to determine if this 5 rounds up or stays a 5. 5 or above, we give this a shove, so this will be 11.6. Okay, for the parallelogram, we have AB equals 11, BD equals 20. Find the lengths of AC and ED. Okay, so you can use some knowledge of parallelograms. You can use some knowledge of similar triangles here. Um, Basically, in a parallelogram, this triangle ABD is similar to the triangle EBC. Okay, those two triangles are similar. So that means if AB is 11, then BC is also 11. Okay, so if this is 11, then this is 11. So it's asking for the length of AC. So if this is 11 and this is 11, then this whole diagonal here is going to be two 11s, so 11 and 11. So that side will be 22. Okay. Likewise, the other diagonal, it's saying that BD is 20. So if BD is 20, then EB is also 20. So that means ED, the other diagonal, is going to be 20 and 20. So 20 plus 20 is 40. Okay, and then we have on the blueprints of their new home, Paul and Greta notice the balcony is 9 inches long and 4 inches wide. So this is the blueprint. They know that the actual balcony will be 11.7 feet long. How wide will the balcony be? Okay, so here I'm going to do actually, we can do it either way, I believe. So I will do the dimensions of the blueprint. So it's 9 inches is the length and 4 inches is the width. So this is length and width. So that means in my proportion of the actual balcony, it has to also be length over width. Okay, so here I have 9 inches by 4 inches. So the other dimension here will be, I know that the length is 11.7 feet long, and I need to find the width. So even though this is inches and this is feet, because it's proportions, it actually doesn't matter. I just know that my answer is going to be in feet, which is the unit that I want. Okay, so we have this proportion to solve. So now I'm going to cross multiply. I have 9 times x, which is 9x, equals 4 times 11.7, which is 46.8. And then to solve, I'm going to divide both sides by 9. And I get 5.2 is equal to x. And it says a whole number or a decimal, so 5.2 feet is fine. And that is the last question. Okay, so that is it for 10.2's post-test.